Hello,
Hey, how's it going, GM?
I'm well. How about you?
Doing pretty good, doing pretty good. And it's 5
Awesome.
a.m. here in SF.
Perfect, perfect.
How are you? How's it going?
Doing well myself. Wait, I have a dirty camera. Give me 1 second so I can turn it on.
No worries. Hey, everyone. We'll let
Hello.
everyone go a second. Welcome to another ecosystem workshop for NoirHack, GM. This is being recorded for everyone who's joining through the recording. Want to introduce you guys to DC Builder, who will be joining us for a workshop. Before that, a little housekeeping. For NoirHack, we have our show and tell that will be this Friday. The sign up deadline for that is on Thursday. So if anyone is interested in participating in the show and tell, it's like a good way to prepare for the demo day that's coming up on May 12th. So be sure to sign up. And yeah, today DC Builder will be walking us through an intro to World and their upcoming client-side proving stack. So he'll be going through what they're working on with Noir and how to build identity with privacy for everyone. So I'll hand it over to DC Builder to start walking us through everything.
Awesome, awesome. Thank you for the great introduction. Cool. So I'll start sharing my screen if I find the right one to share. Okay. Uh, do you see my Figma?
Yes.
Yes. Okay. If I go full screen, let me see, let me know if you still see it after I full screen. Do you still see it?
Yes, can still see it.
Okay, awesome. Cool. So why is it? Oh, there we go. Cool. Now it's full screen. Awesome. I'm gonna give an update. Yeah, I'm gonna be talking about our client-side proving stack, but before that, I feel like it's good to set some context behind what we're doing and what we're interested in, and what we're all about when it comes to cryptography and identity. I'm DC Builder. I'm a research engineer at the World Foundation. I mostly work on applied cryptography and blockchain-related things. I've been at the project for almost 3 years, and when I joined, I was working mostly on World ID as a Solidity and Rust engineer. And nowadays, I'm doing lots of coordination with third parties on different topics and trying to push the project forward wherever I can. So I wanted to start with a general introduction so that people are sort of have good context on why we care about cryptography, why what we've done so far in this area, and all that jazz, all that good stuff. So World, I would say the main four things that you might have heard of, the main four products are World App, World ID, World Chain, and Worldcoin. So World App is the client for interacting with the World ecosystem. It's an iOS and Android app that you can download and you can use, and it gives you access to two main things. One is World ID, which is your privacy-preserving proof of person protocol, and a safe smart account. Or a smart contract wallet, if you know it under that name. So essentially, World ID uses two main technologies. One is MPC and the other one is ZK, in order to have a fully privacy-preserving way to prove you're a unique human online and on-chain. And for that, we've used Groth16. We use the semaphore protocol under the hood for proving inclusion in a set of verified humans. So that is like Groth16, Circon, like Trad, ZK, if you will. Um, and for the MPC, we built our own MPC system, essentially to make sure that the embedding of the iris biometrics, called the iris code, is stored in a fully privacy-preserving way, encrypted and never in plain text, so that you can measure uniqueness between each user. So those are the two main things, or two main areas where we've worked a lot on cryptography. And one thing to note is that all of the cryptography that happens in the world ecosystem happens client-side, for the ZK side of things. So all of the users are creating proofs on World App, and there's 25 million users that have World App downloaded. 12 million of them have been verified by the orb. And whenever they're doing an action with World ID, they're creating a client-side ZK proof. So for us, it's paramount to have a really performing client-side prover for any of the products that we do that involve identity, because we never want the witness or the private data to leak the user's control. Everything is fully self-custodial, and none of the biometric information or anything else about the user ever leaks their device. And so yeah, WorldChain also, maybe for good context, is an OP Stack L2, part of the superchain, and it's where most of the transactions around the world happen, especially all of the transactions for World App. Cool. So I'm just gonna blaze through to not bother you with the general stuff. But this is the orb. This is the device that we manufacture and distribute worldwide across many markets to onboard people and verify them to be unique humans. There's all sorts of different cool things like an infrared camera, RGB camera, a field of depth camera, thermal sensor. Um, and you use that to measure that the person in front of the device is real and unique. And there's also an onboard GPU and CPU, full operating system, battery, and a bunch of other things like a liquid lens and mirrors and things to make the image quality really good. So this is what it looks like, right? You can this is what World App looks like. You can schedule yourself to get verified. You can use the wallet. You can like buy and sell assets on ramp and off ramp easily. And this is the one that we're going to be talking about today. World ID, right? So currently, this is a mock-up. This is not what World ID the tab looks like. You're in the current tab. You're going to see this, and the passport as well, but you're not going to see ID card or phone number yet. But essentially, we're working towards a world where you have World ID credentials, and you can onboard yourself with many different kinds of credentials all around the world, and you can ZK proof everything about your identity through that, which I'm going to show you a bit more later. These are mini apps. So there's a third-party app store on World App. You can download mini apps, and as a third-party developer, you can build applications on World App and serve them to our 25 million plus users across iOS and Android. And so you can also like use this as a distribution platform for your crypto applications. So this is a presentation I gave at ETH last week, so I'm gonna skip through this side of things. Cool. This is just some cool data about how many users we have and transactions. I won't bother you with these are like if you want to check some data out on our growth statistics. This is actually a good resource. If you've ever had any questions around the privacy guarantees, the hardware, the biometrics pipeline, anything else, feel free to refer to this resource, and you can have an in-depth explanation about all those things. If I were to explain all of those things, it would take me hours. So if you ever have questions about that, feel free to refer to this resource and our blog post for any news and updates. But let me blaze through to what we are here to talk about today. Cool. So what I want to talk about is our client-side proving stack. So as I mentioned, all of the ZK proofs that happen on World App happen on World App, right? So World App runs on an iOS or Android device on the user's devices that have World App around the world. And if you look at the sort of distribution of phones, especially if you look at like the lower end of devices that run World App, it's usually like some old Android phone from 2013 with like 2 gigs of RAM, very, very old CPU core. They don't have a lot of internet connectivity. They don't have a lot of storage. So things like binary size become important, right? Because maybe someone can only afford like 100 megabytes of data a month or a week. So they like you cannot just keep updating the app and like adding new provers. You have to care about like having a transparent prover, because if you increase the size of the circuit, then like for like specific proof system, you're gonna have to download things like trusted setup files and all those things. So there's a lot of constraints that world faces while building applications that are distributed to people all around the world on low end devices. And so these are sort of some of the constraints that we have when building cryptography. And so what we ended up coming to is that the state of the art that we're looking at was not performant enough on mobile devices. And so we decided and set out to build our own client-side prover. Currently, we have a code name for it. It's just called ProofKit. Um, but there's still a lot of things that we're building at the moment. So some of the things I'm going to show are still a work in progress. But we're really getting to that. So what we decided was that since we really want the developer experience to be really good and to be able to reuse some of the applications that have already been built out in the space and some of the infrastructure. And we decided that the best application or the best programming language for that was Noir. ZK VMs are still not performant enough to run on clients. And out of the other DSLs or proving libraries, the one that had the best ergonomic user experience and good performance and ability to abstract things away on the backend was Noir. And there's already like a really buoyant ecosystem of different applications like ZK email. There's web proofs. There's so many other things like collaborative snarks and a lot of cool applications that we wanted to support. And so Noir was a perfect fit for us to choose. So I'm going to be talking a little bit about the stack that we chose. I'm not going to go too much into the details, but I'll go over it briefly. So in our proof kit stack, we start with Noir, and then we compile that to the Noir intermediate representation. So far, this is the same as with traditional Noir, but everything from Noir Acer lower is different. Noir compiles from Acer to a backend called Burdenberg, which supports the latest flavor of Splunk, which I forget how it's called at the moment. Rafi, maybe if you remember, I think it's like Mega Honk or Mega Honk, something like that, I think.
It's a honk. It's just honk. Yeah.
Okay, awesome. Yeah, the names are always funky and Aztec World. Cool. Yeah, so that's like where we start to differ. We don't use Burdenberg, but we built our own custom backend. Our own custom backend uses a proving system called Spartan, developed in the 2019s, 2020s by Srinath Sethi and the Microsoft team, the Microsoft research team. And so it's a client-side prover that is transparent, is really fast, and we're using a really new commitment scheme or PCS called Where. And this allows us to prove something really fast on the client. And so the properties that these proof systems have, or this combination has, is that it's really fast client side. It consumes very little RAM. You can parallelize it fairly well, and it doesn't have a lot of the expensive operations that mobile chips struggle with. The only problem is that the proofs are fairly big, but they're still kilobytes. So things like computational or just bandwidth, like network bandwidth, are not an issue for these kinds of proofs. And then we send them off to a server once we accomplish ZK, right? So the things that we get on the client are ZK and soundness, right? So we know that the proofs are not fakeable. Like you always need a valid witness to create a valid proof. You cannot fool the verifier. And you have VK, meaning that the witness has full privacy on the client. And then this semi-big proof, we send it off to a server, which has a GNARC sort of recursion circuit. GNARC is a library built by Consensus, which does snarks, right? They do support Gros16 and Plonk, and it's a Go library. So we implemented a GNARC circuit for using the Gros16 backend they have to recurse these Spartan word proofs on the server to achieve succinctness, because we still care about verifying these proofs on chain. And the most succinct proofs that you have for on-chain verification, and the cheapest ones are Gros16, because the EVM or the Ethereum virtual machine has precompiles that allows you to verify elliptic curve operations over the BN254 elliptic curve for a lot cheaper than any other cryptographic system at the moment. And then those proofs you can verify on the EVM, right? Or on the world chain, in our case, for all the identity use cases. So I know that was a handful. Feel free to ask me any questions during the presentation. I don't see them right now, but once I exit the slides, I'll be able to answer any of them and show you throughout the slides. So this is our general stack. But what does this actually enable, or why do we care so much, right? I mentioned earlier that the constraints that we have is that if you want to do any identity proofs with full privacy, you care about the identity credentials living in a self-custodial manner in a device that the user controls fully. You don't want to ever leak the witness to a third party to create a ZK proof. And you also ideally would not want to use things like trusted execution environments or some form of delegated proving or collaborative snarks, because you care about network bandwidth as well. One of the reasons why we cannot use something like Noir from Tasio is that a lot of our users, especially for the ones that we really care about making client-side proving performant for, do not have access to a good internet connection. Maybe in a few years, once everyone has a Starlink connection or some other like low Earth orbit satellite internet provider, they have access to that for fairly cheap or for free, ideally, then maybe we can do collaborative snarks. But right now, we really care about having fast performance provers on the devices that are already distributed out there. And so the thing that we care about is having a performing client-side prover, right? And so this is why we've been building this system, because a lot of the use cases that we want to do are cool demos that already work, but they usually work only on flagship devices like the latest iPhones or the latest Android phones across the board. But if you want to prove them on a World App user device, on the user device of a World App user, it's pretty much impossible because the prover would run out of memory. They would have to download gigantic like circuit descriptions and trusted setup files if you're using Graph 16. And it's essentially a lot of the use cases that we want to do, things like proving things about information on your passport or your government ID or your social media account or on-chain activity, or creating proofs of for example, transacting on Aztec, right? Like if I'm spending my Aztec note and sending someone a balance or interacting with an Aztec smart contract, you also need to create that client-side proof if you have private state. Um, so yeah, a lot of those bottlenecks are really present when you were actually exposed to low-end user devices, which is something that we've been working on for a long time. So right now, what we have is World ID, which allows you to prove that you're a unique human. And it also is, we've also started rolling out the passport side of things, which allows you to prove that you own a unique passport. But things like selective disclosure have not been in production yet, mostly because of performance issues, where if you want to do a selective disclosure proof of passport data, let's say that I want to prove that I'm over 18 or that I'm from a specific nationality, it's really hard because these passport standards usually use cryptography or ZK cryptography unfriendly um, uh, tools or schemes like the RSA signature or a SHA hashing function. And so these circuits, or when you want to do these things in ZK, they have a really high blowup factor, which means that these circuits like are really hard to represent in ZK, and it's be rude, making it impossible to run on device. So this is why we've been building everything that we have been so far. So I'm gonna skip through these, and I'm happy to show you more. Also, I wanted to mention that we have an event at the end of April, so in a week and a half almost, in San Francisco, announcing a lot of the new updates that we have. So stay tuned for that one if you're curious to learn more. Cool. So I'm gonna show you my GitHub. Let me check if someone
What
asked any questions.
Yeah, one quick question was asked about if World is using T's, and if they are, how they're using T's. And then also a correction. I said that we were using honk. We're actually using ultra honk now. So that is a more recent change. But yeah, that's the flavor
Mhm.
we're currently using.
Yeah, that's why I asked. Like, it's always changing. Uh,
Yeah.
awesome, awesome. Yeah, I don't know if you can hear, but my laundry machine is going off.
Oh, no worries.
Cool. Okay. Awesome. Cool. It ended. So yeah, the first question, T's. We are using trusted execution environments, but not for any of the ZK side of things. We only use T's where it strictly adds security. We're not using it as a replacement for like privacy. In our MPC setup, um, actually let me share my browser screen at the same time. I can share the AMPC blog post we published. Uh, well, I think it's this browser. Cool. So I am just going to show you our AMPC blog post. AMPC stands for Anonymized Multi-Party Computation. It's just a different word for secure multi-party computation, but anonymous makes it more obvious in the branding of it. So in our AMPC setup, we have this three-party setup, which keep the shares or as they're called in formal terms, linear secret shares of the iris codes. So each user, when they create a world ID, they get they get an iris code pair, or like the orb computes that they're unique by computing an iris code pair and checking that their iris codes or iris embeddings are unique compared to all of the other users that have signed up so far. So if I find the right place here, here, so every user, when they sign up, the orb checks that you're a real human being through all the sensors. And after that, using this thing called the Gabor filter and an ensemble of them called the Gabor wavelet, which looks like this, it computes an iris code, which looks like this. And this iris code pair, you can compute a distance transform against all the other iris codes. And so these iris codes, we don't store them in plain text. We don't store them like you see them here. We store them in MPC. And in the MPC participants, they not only use MPC, meaning that there's privacy with a 2 out of 3 threshold, and these parties are operated by credibly neutral universities, the University of Erlangen in Germany, UC Berkeley, and the University of Zurich. And we're adding more parties as we're speaking with other universities and parties. But not only are we using MPC, but we're also using TEs. So each MPC participant is running inside of a TE. And fun fact, since our MPC is really like compute intensive, all of them are running inside of NVIDIA GPUs with CUDA kernels. So it's like really performant AWS servers with NVIDIA GPUs that also have a TE in them. H100s and H200s have TEs directly embedded in them, and so you can attest to things that are happening inside of the graphics card, and so that's why we're using TEs, or where we're using TEs. Hopefully that answered the question. What was the second question? I think I'm forgetting.
It was just around teas. There was one question around teas.
Oh,
I think
just
that you
one
yeah
question.
answered.
Awesome, awesome. Yeah, I know it was a lot. I just don't want to take too much. Okay, I think we have a lot of time. Okay, if you still have questions about that, I'm happy to go deeper into that. But what I wanted to show is ProofKit, which is our Noir backend. So ProofKit, if you go to github.com/worldfnd, World Foundation /proofkit, you can download this Git repository. You can download this specific commit hash for Noir using the Noir up tool, which allows you to download a specific version of Noir and the Brandenburg backend as well. And the thing that changes here is that instead of using Noir's Brandenburg backend, you're going to be using our backend for creating these proofs. So in this example, which I'm going to try to run, I don't know if the main branch is broken at the moment because there's a lot of things changing. It's not a public release, so I don't know if it's going to work. But in a moment, I'm going to show my terminal or my browser, sorry, my IDE, and we're going to try and compile this. So if you just do the set of steps, now I'm just gonna do it myself quickly. Uh, do, do, do. Yeah, if anyone has any questions, feel free to ask me while I'm downloading and cloning the repo and making sure I have Noir at the right version so I can share my screen. Do, do, do. Also, it's nice to see a lot of the Aztec people in Seoul last week. We met up at the ETH Seoul event. Good to see the fam around the world. Sorry for the improvisation here. Downloading the Noir version. And I'll open VS Code once I finish. But yeah, what we're going to be doing is we're going to create, we have a circuit that does a Poseidon hash. And in our current benchmarks, our backend is about 17 times faster than Brandenburg. One thing to note is that Brandenburg gets ZK for free, or like Ultra Hong gets ZK for free, meaning that The difference between creating a soundproof and no ZK and a soundproof with a ZK is about the same computationally speaking. But for us, we're gonna incur more delays because we have to do an extra FFT, fast Fourier transform. And so the benchmark numbers that we have right now with the 17x speedup is not going to be the end benchmark. The current thing that we're working on is getting our proving system to have ZK because the where polynomial commitment scheme that we have is not ZK by default. You need to do some extra theoretical work that we had to do to add ZK to it. And so that's what we've been working on over the last few months before we're released to production. Okay, let me see. Okay, this sounds like the right tab. Can you see my screen?
Yes.
Awesome. So let me just double check I have the right version of Noir. I should have it already. Worst case, it's just going to install again. But yeah, the thing that this is composed of is a Noir to R1CS backend. So for Spartan, we're using this version of R1CS or rank 1 constraint system that is called GR1CS, which allows you to do things that are not only quadratic in nature. You can do like polynomial gates with higher degree constraints uh, and some other goodies. And you can also do lookups and custom gates, which for R1CS, vanilla R1CS, you cannot do that. So we're gonna be like also using the lookup and custom gates API for Noir, I believe. I'm not one of the developers on the project, so some of the things I just said might be wrong. But the Tools for Humanity Applied Research team and some of the researchers at the foundation have also been working at this with a lot of third parties as well. There's, for example, Ngonyama working on a lot of the low-level optimizations for phones and plenty of other teams. So what we're going to be doing now is we're going to go into our examples folder and we're going to compile it with the current version of Noir that we checked out with the commit. This is something that anyone can replicate. Hopefully, if the main branch is not broken at the moment. Okay. So now if we see here, we already have our Privitomo and everything. So we've already compiled the circuits. And if we keep following along the example, we can run the witness generator. This is very, very uneventful, but since this is now currently like under work, the cool thing that for Noir developers is that since Noir is this like really flexible programming language, is that anyone can build their own backend for it. And so in the end, like people are going to be able to choose between like, let's say Ultra Honk, which is going to be implemented in Berdenberg, our proving backend, or any other proving backend based on their own needs. This is like something that is really great for from having like really quality open source software. One thing to note though, okay. Yeah, okay. Probably this branch is broken for some reason, so I'm not going to be able to show the end-to-end thing at the moment. But one of the things that I wanted to talk about is that since Noir is this like open source programming language that people can contribute to, or fork or change parts of the cryptography, is that it allows like a lot of third parties like us to adapt the tool for the things that we need. And so I wanted to really commend a lot of the hard work that was done by Aztec for the last 8 years, so as to welcome all these third parties to collaborate and build better ZK tooling together. Because we benefit a lot from having existing tool chains that we don't have to reinvent the wheel for. And we can all improve the same tool together, which is great. So what this is going to allow people to do is that we're going to have like any Noir developer is going to be able to write a Noir circuit and compile it with our backend and run it at performance screen again. Oh, Daniel Arroyo, the non-quadratic restrictions is a very cool thing there. Yeah, yeah, yeah. I think that is the case currently. Because that's what I remember, that you can have lookup tables and custom gates from GR1CS. Let me go back to my presentation. So one of the things I wanted to mention is that one of the things I would like to see personally is that in our mini apps ecosystem, where you can build third-party applications on WorldChain and on World App, one of my personal sort of feature requests is that you could bundle a Noir compiler directly in the World App. And so any third-party developer, they could have a Noir API for mini apps. Many apps already have existing APIs that use the World App runtime for. So you can have things like push notifications for your mini app. You can use or trigger transactions from the World App wallet. You can interact with World ID. So one of the cool things that would be great to have is not only have the World ID actions like proving things about your passport or any of your other credentials that we're going to support, but that for any third party to be able to create any proof of any kind about their identity and like use their own circuits in the app. And as long as you define a schema that allows the user to know which things they're creating proofs about, it would be great to have an ecosystem of like third-party identity protocols and use cases that people can build on their own using Noir and mini apps and distributing that like privacy preserving applications everywhere um, through that venue, right? I honestly good chat. Rafi, what do you think would be best to chat about next? We do have like another half an hour, and
I think it
I
would
don't.
be.
Mhm.
Oh, sorry. Go ahead.
Yeah.
So there's a question in the Q&A about like what would be useful to build during NoirHack. So I think it'd be interesting to maybe go
Hmm.
into some potential examples of things you'd want to see built.
Hmm.
And to answer that question, then we could just kind of explore maybe some like potential use cases for some time.
Hmm. Awesome. Perfect. Right. Yeah, that's awesome. Yeah, I'm one of the judges as well. If I remember correctly for NoirHack. Yeah. So what I would like to see personally, I mean, a lot of the things that I've not seen is real world applications for ZK. I feel like a lot of the things that we've had is a lot of tooling, a lot of infrastructure, a lot of or maybe like applications that maybe don't impact the average person, I would say. Maybe like high value transactions for like whether it's DeFi or some other form where ZK is valuable, or like rollups usually is the thing that people have used ZK for. But Noir is a language that directly aligns itself to building more than just like financial applications or more than just infrastructure. It's very similar to Rust for if you're a Rust engineer, and so you're able to build a lot more verbose applications and something that looks more like an application rather than just some arbitrary smart contract or program. So something I would like to see is just go wild on your imagination of like what are applications that could average that could impact the average person out there. For us, what we're building currently is creating proofs of your identity, right? So proofs of your passport credentials, proofs of your email through things like ZK email. There's teams building web proofs, which allow you to create proofs of any information that is held inside of a website. So some of the teams that are building that are, for example, Pluto, Reclaim, Opacity, and I think a few other teams. Um, but a lot of the tools I feel like are already ready, but there's not a lot of applications that use those tools that allow you to create proofs of these different identity primitives in some meaningful way. So something I would like to see in the hackathon is that, right? Like build a full stack application that uses Noir, uses ZK in it, either for doing identity things, creating proofs of identity, or creating proofs of actions that were done in some way or some computation that was meaningful to prove to some third party something about yourself or something you did on your computer or your phone, but something that would enable the normal person or the average person to do something a lot more that they couldn't do before. Would this be in the form of World Mini App? Uh, well, you could do it as a world mini app, but the problem right now is that mini apps are just a web app. And the web app side of things is that you don't have access to the phone runtime. And currently the phone runtime does not like allow you to do third party like remote or like third party code execution. You can only like render some JavaScript through a web view. And so if you want to do ZK, you do actually need to run the prover. And right now we don't have a prover API. We only have a world ID API, so you can only run semaphore circuits, which are already bundled in World App, but you cannot like compile your own circuit with a mini app and run that on the user's client. And so if you have actual data that you want to create the proof about, the best way you could do it is like have another native app or a React native app maybe, and you can symlink or deep link between World App and that third-party app. Where if let's say you need to do a proof, you need to go back and beyond. Yeah, that's why I mentioned it. Because you need to have the prover running on the user's device if you want to have like ZK client side. Uh, yeah, that's like my personal dream, right? Like you have a Noir compiler, you can have an arbitrary circuit description and the public input structure, and you have a way to define that as an API, like what data or what credentials you can have a decentralized way of creating credentials or like a structure to those credentials. You can think of things like what is this proof carrying data thing, PCD from Zupass, right? Like Zupass for example, allows you to define your own credentials, right? Or any other protocol allows you to create like your own third-party credentials. You have a schema around the public input for those credentials, and then you define like where this root of trust is, and the user knows which data they're using to create that ZK proof, and maybe which data leaks if some of the data is a public input and and then you could do like any arbitrary statement or programmable ZK predicate about your identity. That's like my personal dream because I know that like the use cases that we're going to build are going to be useful and powerful, but in the name of decentralization, people should be able to build any arbitrary identity use case or beyond that and use the existing open source tooling and the centralized tooling that we have to enable a user in ways that maybe no, we would have not come up with even. Um, yeah, UltraHawk supports WASM in browser. Maybe, but I don't know how performant that would be. Um, like the one of the reasons why we didn't use UltraHawk, I don't know exactly all the details, but I believe what one was performance, two was memory consumption. It was consuming way too much memory on the phone. So one of the constraints that we have is that we have a 2 to the 24 constraints circuit benchmark, which we want to prove in under 1 minute, and using ideally less than 1 gig of RAM or like something around the figure of 1 gig of RAM for that. And so. Yeah, like you could bundle Ultron as in WASM in the JavaScript app you're serving over a web view, but I don't think that would be performant at all for anyone in that specific case scenario. And our backend is not yet ready, so you can bundle it like that through WASM either. So I believe that will not get you very far. But yeah, it's definitely a possibility. It's just like for a mini app, it would be hard. It's better for you to build your own native app and bundle your own Noir prover, maybe using UltraHonk currently. But in the future, like in a few months, once we have our prover, you can use it. Also, I had some chats with Zach. Once a lot of the things around launching mainnet for Aztec, there's also like if our backend is just better, it also just makes sense for everybody else to use it. If it ends up being just strictly better than UltraHonk or Bardenberg. Yeah. Uh, is there anything else I can think about for NoirHack?
I think it could be useful or interesting to get an understanding as to actually in the like initial NoirHack page, we had cited like some tweets of yours where you just talked
Hmm.
about Noir as a language. So it'd be interesting to get your take live on what specific features of Noir made it like a language choice for you guys at World, and how maybe it compared to like other stuff for like your proving stack, like Circom or these other languages, and maybe also how you're thinking about it in the long term and how you might use it for world going forward.
Hmm. Yeah, 100%. I'm happy to walk you through that from first principles. So Circom was great for like 2019, right? Like going from using things like Rapid Snark or some other framework to using Circom was 0 to 1 moment where people were using like writing constraints by hand pretty much before. There was no real compiler that you could use that was production ready or that you can like use in any fashion. Also, doing things like trusted setups were really painful, and so Snark.js at least allowed you to do trusted setups in some simple-ish way, right? And eventually, it got automated by PSE with things like Potion, which is a tool that allows you to host sort of trusted setup ceremonies easily, and like they can host them for you, and it's quite easy to do nowadays. But Sercom is still outdated. I don't know if anyone's played around with Snark.js or has had to read Jordi's code. But it's not like up to standards with current state of the art, right? Like if you look at other tools like Plonky 3 or like the ZKVMs out there, or you look at some of the Benius proving systems, or you look at the Starkware like Stu and their other tools for Cairo. Essentially, there's like a lot of like newer backends that are much faster and more performant. They have all these new features like folding, like binary tarball fields, etc. A lot of them are really nice and performant, but they're really hard to target. They're really hard to write constraints for, and you really need a cryptography engineer to know how to write circuits, right? So a lot of the teams building ZK were able to do that because they had in-house ZK cryptography experts that were writing these circuits for things like ZK VMs, right? Like think of ZK Sync, Matter Labs, Polygon, ZK VM, Polygon Maiden. Um, you have teams like all the other like Scroll, etc., right? And so that is great, but for the average developer, it's really hard to like learn something like Narc or learn something like Plonky 3 and be able to use their builder API to build a circuit. And so for us, the thing that we wanted to use is, okay, like what would be a tool that would allow us to be a lot more productive and not have to like worry about the feet changing, like or like the ground changing underneath our feet. Because like if you ever like let's say there's a new identity standard, new hash scheme, whatever, to implement that in a raw block builder is a lot harder than do that in a ZK DSL. Ideally, you would do it in a ZKVM, but ZKVMs have so much overhead when it comes to like simulating memory, simulating a CPU, simulating like clock cycles, and all of those things that it's really impossible to do anything that doesn't use like 8 gigs of RAM or more, or like 16, for like running SP1 or RISC-0. And so Noir has it all, right? Like it has a really good developer experience. It's inspired by Cargo and Rust, so it has a great set of tools, right? Nargo is pretty much like a lot of the APIs are similar. The tool chains, things like the LSP, the compiler, the abstractions behind the language is very flexible. It was built by people like Kev Andre and like really other great compiler engineers and people who put a lot of love into it. At first, it has like some rough edges around it because it was built with a use case in mind, right? Like it was built for Aztec. It wasn't built necessarily for third parties to use. But over time, it's become much more friendly or easier for other parties to adopt it. And right now, we feel really comfortable with that in the sense that we have now a language that is ergonomic, Rust-like, because we all of the things we write are in Rust, like from the orb firmware to some of the biometric side of things, to cryptography, to blockchain, like node, like a lot of the in-house expertise, like 90% of engineers write Rust. So Noir is also like lends itself well to that. There's a lot of third-party tools already built in Noir, so we benefit a lot from the ecosystem growth, right? There's ZK email, there's the Tasio guys building collaborative snarks with Noir. There's I'm sure I'm gonna forget a lot, but there's also like implementations for existing tools and circuits for things like hash functions, signature schemes. Um, Yeah, there's just so much that you benefit from that we don't have to build ourselves from the from ground up. The PRs get reviewed. Things work fine. And when it comes to performance, is the best compromise of all worlds, right? Like it's developer friendly and user like the user developer experience is good, but at the same time you can squeeze maximum performance and fit within our constraints of all the client side proving stuff that we're doing, which is really hard to do. A lot of the teams have been building like ZK apps, but it's really hard to do them on clients that are underpowered, especially like mobile phones, in let's say like Brazil or Argentina or somewhere else where maybe like the average person or like the lower end of the spectrum doesn't have powerful phones to crazy keepers on.
So a quick follow-up. So you mentioned like some of the benefits around like tooling, especially libraries that exist, some of the like primitives as well. You kind of referenced. What do you think lately has been the most useful that you've found for building like production applications for building with Noir?
Resources or what specifically you mentioned?
Resources is another question, but I guess like so you mentioned like things like Nargo, the LSP, ZK email, different primitives that are built into Noir. So of these, are
Hmm.
there anything like is there was there a moment or a thing that like you're like, wow, this is going to be really super helpful for us, or just like maybe just the DevX was so enjoyable. Any like
Hmm.
particular things where
Hmm.
it really felt like okay, Noir is just like a great language.
Hmm. Admittedly, I have to say that I don't really write circuits that much, or I've not used Noir that much personally. I'm mostly waiting on a lot of things to for us to have the client side prover before I start working on some projects. But the thing that I liked is for the time that I did like do go through the templates in the docs, etc. It's like really easy to go 0 to 1. Like you can get like you can write a smart contract, compile everything very easily with a few commands. It's not like with Snark.js where you have to like learn a lot of the things. Like writing circom nowadays there's things like REPLs, etc. But like when I was learning ZK for the first time, it was really hard to understand even what a constraint was like. So not having to handwrite constraints and just having a human-friendly um, language that I can write things in, and at the same time not have to worry about a lot of the lower end of the spectrum, but not sacrifice performance is really great. Some of my friends, I mean, the things that what they've been telling me about Noir is that even though it was rough around the edges, maybe like a year ago or when they first looked at it, it nowadays is like getting a lot more like robust, and they're seeing like less random seg faults out of the compiler when they're trying to push it around the edges or things. So it's becoming more stable, especially since the 1.0 release. I think it's already 1.0, right? I'm not misquoting that. Yeah, okay. Yeah. Ever since the 1.0 release. And so a lot of those things are that, right? It's just something that is easy to pick up for the average developer off the shelf. I can have a friend who is like maybe a Rust engineer. I can just tell them like, hey, you can do ZK with this now. And all of the semantics of the things they learned with Rust, like the borrow checker, etc. Like a lot of the things are preserved in Noir. So it's very easy for them to get on ramped as opposed to like telling them like, hey, go learn this like really obscure API that doesn't abstract any of the ZK things for you. Like, you have to learn what a zero gate is. You have to learn what this is. You have to work within the sort of constraints of writing ZK circuits, and you have to know what the limits of the proving system you're using are, so that you don't like have a foot gun or you under constrain your system, etc. A lot of those things are sort of what I like about Noir. And nowadays, in the age of LLMs, it's just so easy to do. Right? Like you can have like an MCP for Noir for the docs, etc. And the more code you produce and the more code it's fed, the better it is at reasoning. So yeah, I feel like nowadays is like really easy to learn a programming language, especially if you have LLMs and you can just like play around with that.
Yeah, on that point, we have an AI bot now in our Noir docs, which is quite helpful. So for those of you guys who are here, who are excited about building on World and in the NoirHack program, if you have like specific Noir questions, even related to World, like you can, what one is you can just ask the questions in the docs with the AI bot, but then you can also just use cursor and pull the proof kit and then add the docs. Um, I guess another question. So you'd mentioned some resources as well. Was there any particular resource that was really helpful for you when you were kind of getting an understanding of Noir?
It's just the Noir docs, right? Like people that write Rust, I guess usually like the experience of the Rust book. So I guess you can call it the Noir book. The examples are quite nice, like very easily, like just git clone, go through them. You can see example circuits. And then I went through a bunch of the example code bases. My friend Ayush built ZK email, so I was looking at a bunch of the ZK email, like ZK regex ones, or the some hash function implementations, and some other things. I know there's some people like there's so many ZK passport teams. I think they're literally just called ZK passport. This team, like Michael and blanking
Theo?
out. And Theo, yeah, Michael and Theo. I've looked at their circuits as well. So like when I was like checking it out, is quite straightforward. Like the code is idiomatic. You're not trying to like parse some obscure thing, unless it's like okay, like a hash function is still gonna be obscure to anyone if you even see it in like written in Rust or something, because like there's a weird thing happen like as boxes and shuffles and things. But yeah, it's just understandable, readable, easy to clone, run it, and you don't run into a lot of issues nowadays anymore. I see one
It seems
question
like
from
yeah.
Kian. Does the proof kit support Graph 16? So I answered yes and no. What I mean by that is that in the end, the thing that you get from our proving stack is a Groth16 proof to be verified on the EVM, but ProofKit itself, the proof that is generated on the client is not a Groth16 proof. It's a Spartan proof that uses where as the polynomial commitment scheme, which then gets recursed server side. So once you already have ZK client side on your phone, that proof gets sent server side, and you can aggregate that with like hundreds of other Spartan proofs, and then in the end you can have like one Groth16 proof. Of course, you're limited by the number of constraints of Groth16, which is like 2 to the 28 for the powers of tau. So you can have up to 2 to the 28 constraints for aggregating all those Spartan proofs and verifying them recursively. And in the end, you do have a Groth16 proof. But the backend for Noir itself is not generating a ZK, a Groth16 proof. The Groth16 proof is created by Gnark, which is a Go library built by Consensus. Hopefully that answered the question. Cool. I found this awesome Noir apps link very helpful. That's good. Okay, I already have it started on GitHub. Maybe I forgot that I took a look at this at some point.
This one is
Yeah, that's
also like
nice.
a good resource we typically point people to. I have maybe a few more questions in the last couple of minutes. I guess what as like Noir is evolving, are there any like features or changes to the language that excite you for improving like World's identity stack? And what of these improvements would be useful for you guys, like in our tooling, would most benefit developers building with World or just you guys in general as you maybe write more Noir?
I think right now it's hard for me to guess or to say ahead of time. As I said, like I've not really written that much Noir myself. I've mostly gone through like tutorials and played around and like read some circuits, but I've not really built a production app in Noir just yet. Um, so it's hard for me to know like what things would be good. I guess some of our research team, formerly known as Modulus Labs, we acquired them last year. They're now part of TFH. They're building like a lot of the client-side proving stuff that we're using. Now they would have some thoughts, I guess, around the Noir compiler, etc. Um, One of the things that was hard was just like looking at Burdenberg. Like when we open Burdenberg, you just see like a bunch of C++ is the first thing that makes you like think like, I don't want to touch that. I want to contribute to that. So I don't know, maybe like a Burdenberg RS or like Ultra Hong RS, that would be cool. But since we're building our own backend, I guess that's less relevant for us because we're like building our own stack. But yeah, like when we first came to it, Burdenberg is like a thing that like looks scary to all the people like trying to contribute to Noir on the performance side of things or on the cryptography side of things. But I guess it's because like a lot of the early engineers that joined Aztec were C++ engineers, and that was like the what was chosen at the time.
Awesome. I guess maybe one final question. So we talked a little bit about use cases, maybe for those folks who are building with World, maybe one last suggestion as to like what they could look forward to building.
Hmm. So, one thing that would be cool was if you could do like a World ID implementation in Noir. So I know that there's been a bounty for writing semaphore in Noir. I think there's one team that built it already. I mean, it's not that hard. Like you just implement Poseidon and then you just do a Merkle tree of Poseidon trees and you just ZK proof inclusion in the tree with a Merkle path. So maybe doing like a World ID implementation in Noir would be cool. So for that, the things that you need is one, you need to bridge the root of the tree from the Ethereum World ID tree, which is a Poseidon hash, the root hash of the Poseidon tree that we have. So bridge that to I guess like a demo Aztec. Like I guess you already have the Aztec DevNet thing you can run to deploy Noir smart contracts, right? So yeah, if you can do that, it would be great. Yeah, it'd be great to like deploy a local DevNet, and you can do like a bridge which relays information to that thing, and you can do like a ZK inclusion proof with either using the existing Noir implementation of Semaphore or doing your own and doing a full like proof of personhood, like proving that I am a unique human included in the set of World ID holders, and then you can maybe do like a governance app, right? So you can do a Noir circuit for like your governance app, or a Noir circuit for claiming an airdrop, or a Noir circuit for claiming an NFT or something. Something that is super resistant. That'd be cool, a cool demo with Noir, I think. Currently, our Noir implementation or our World ID implementation uses CirComp for the semaphore circuit, so it'd be cool to seeing an end-to-end demo of it being using Noir instead. That'd be cool.
Awesome. Yeah, I think we now have the semaphore stuff like in Noir, so you could do that in a much more streamlined way. You wouldn't have to like build semaphore in Noir yet anymore. I think so.
Mm.
Cool. Well, you guys heard it here, so I think like if you guys are here and you're excited to build World, you have a couple use cases to look forward to building. DC Builder, I want to thank you again for joining and walking through this. It was cool to, like I said, I'm a lurker, so I've been seeing your tweets for a while, so it's cool to be here with you and get to learn more.
Awesome. Thank you for having me on. Pleasure to be here.
Cool. Thanks, everyone. See you guys in the
Take
next
care,
few
everyone.
workshops. Bye.